Hello class, this is module 2 investigation 1. This is my first video I'm gonna upload in the Blackboard, okay? So 2.1 is about quantities and covariation of quantities. So this lesson engages you to understanding idea of the quantity and variable, two foundational idea for developing formulas and graphs to represent how the two quantities change together. So numbers of days since the March 1st, 2020, the total of the COVID-19 case in the United States. So the most critical step in the constructing formulas and graphs in applied problems is identifying the words that provide the information about quantity. An attribute of some situation or objects can be the measured next, representing these quantities in a diagram can help you to recognize how to define one quantity in a situation in terms of the another using a table, formula, or graphs. So learning to conceptualize and relate the quantities in a problem will unlock your potential to become a powerful mathematical thinker and assure your success in this and the future course in mathematics. Okay, so we're going to think about number 1. So as we work together, the goal to relate the two varying quantities with a formula or graphs. It is helpful to represent the quantities in a drawing that illustrate how quantities in the problem context and context are related. So number 1 says, Arizona State University graduate Desiree Linden won the Boston Marathon in 2018. She began the 26.2 miles race with a slow pace due to the wind and rain. After completing the first half of the race, she increases her pace and completing the marathon in a time of 2 hours and 39 minutes and 54 seconds. So identify the least two distance in this situation that are the constant, which is their value does not vary. And then be sure to specify the value, the unit of the measure, and where you are measuring from. So we need to talk about the two distance constants. So in order to find this, so first one is actually this is not can be changed is the distance, which is in mile. That's a measurement they use from the starting line to the finish line. Which is, we can write as a number. So this marathon distance is, we have a 26.2 miles. Okay, there will be another distance can be constant too, which is already fixed, which is, you can say the distance, which is in mile, from the starting point, starting line, to the halfway points. Of the race, which is that's exactly the half of the mile, which is 13.1 miles. So I found the two distance that already fixed, which is this two that I wrote, but there's another one too. You can think about the distance from the halfway point to the race to the finish line, which is still 13.1 miles. Okay, so that's what we call the constant, which is you can't really change. B, identify at least the two distance that are the varying, which is can be changeable. So what kind of distance has been changing? Well, the Desiree moving, so it's from the Desiree distance, of course in miles, from the starting line. Also, Desiree, the one that we moved in miles from the finish line. And also you can think about it, the other distance from the halfway points. Okay, so there's some more stuff you can write about. All right, C. When Desiree has run 6 miles from the starting line of the 26.2-mile race, how far is she from the finish line? Indicate the Desiree approximate points on the illustration. So if you do the diagram, that's kind of easier. So let's put the Desiree 6 mile, which is this totals the miles of the marathon, which is 26.2 miles. But she's in the kind of 6 mile zones, right? So she only need to run for the 6 mile. So she's right here. And then, so that's the where that you can put the how far is she from the finish line, which is this is gonna be the how far she left from the finish line. So in order to find the distance from the Desiree to the finish line, you have to just subtract the total of the marathon to the mile that the Desiree ran, which is going to be 20.2 miles. D. When Desiree has run 22 miles from the starting line of the 26.2 mile race, how far is she from the finish line? So she ran more from the 26 mile marathon. Now she's in the, she's right here. She ran 22 miles already. So in order to find the distance from the finish line to her, 26.2 subtract 22, which becomes 4.2 miles. So E, as the number of the miles Desiree has run since starting the race increases, how does the distance from the finish line change? So as you notice, the C and D, the starting the distance from the Desiree to the starting line is keep increasing, right? It used to be 6, now 22, and then when she finished the marathon, it will be the 26.2, right? But other ways for the distance from the Desiree to the finish line is it keep decreasing because it was starting from the 20.2 mile in C, and then D has a 42 miles. So I can say that the distance from the finish line change as so her distance from the finish line decreases. All right, so yeah, that's the number 1. And then the F, so now we still have more problem to go over in these pages. So F in the number 1, represent each of the following below the given illustrations. Number 1, the value of the total length of the race using the solid line with a bar and at the each end. Okay, so I'm going in the bar with the end with the bar, which is this is 26.2 mile. And then number 2, the Desiree distance from the starting line using a dashed line with the arrow. So this is the distance. And then the Desiree distance from the finish line using the dashed line with the arrow to the right end. So same thing. I'm using this way too. Okay. So G, as the Desiree run the race, how the length of the line you draw in part F and the part F change, okay? So if I look at if I label it in F, okay, so this is the number 1 answers, right? So that's the total, the marathon distance of the marathon. And then this is the number 2, okay? And then this is the number 3, right? So that's what I put it followed by the direction. So as the Desiree run on the race, how does the length of the line you have drawn in part F change? Okay, so in number 1, actually as the Desiree run the race, the length of the line, which is a solid line, representing the value of the total line, total length of the race stays the same. Okay, But what about number 2, which is the distance from the starting line to the Dejeri, or Dejeri distance from the starting line, which is increases, right? So the length of the line representing Dejeri's distance from the starting line increases. But number 3, I'm going to write in here, okay? So number 3 is the distance from the Dejeri to the finish line, which is the length of the line representing Dejeri's distance from the finish line decreases. Okay. Alright, so H. In mathematics, it is useful to use a letter referral to as a variable to represent the value of the varying quantity. So if you let the variable x represent Dejeri's distance, I'm using here, so I'm doing the H right now, okay? So I'm going to put the x for the Dejeri distance from the starting line, so I'm going to put the x for the number 2. And then so if I put the x for the distance from the Dejeri to the starting line, and that means the distance from the finish line to the Dejeri is going to be 26.2 minus x. So what the number 1, what does the 26 minus 2, minus x represent? That will be the Dejeri distance from, which is in miles, the finish line. And then what are the units? Of course, it's miles. So letter I, label each line that you drew in the part F with one of the term 26.2 x or 26.2 minus x, which is I already did it. So I already put the 26.2 mile, right? And then J, what value of the x assume in this situation? So the x value is gonna be, because the total the marathon is 26.2. The x value is the distance from the Dejeri to the starting line. So the value of x cannot be, oh no, the value of x actually, I want to put it this way first, varies from 0 miles to 26.2 miles. In this situation. Or you can also say that as the value of the x cannot be less than 0 or greater than the 26.2 miles. On the that's for the J, okay. And then K, true or false question. So the value of the 26.2 minus x varies the Dejeri to run the race. True, because it keep changing, right? True or false? The expression 26.2 minus x represents the Dejeri's distance from the finish line in terms of her distance from the starting line of x. And explain what in terms of the means in this situation. So it's going to be the true, which is the Dejeri's distance is actually the keep changing by the distance from the Dejeri to the starting line. So in terms of means, you need to write the expression with only the x by itself. So which is 26.2 minus x as expression, which that's the distance from the Dejeri to the finish line, and then wrote it as expression in terms of x, because that expression only contains x. The letter L, as the value of x, the Dejeri distance from the starting line in miles increased from the 0 to 26.2. Her distance from the finish line, which is increase or decrease. So distance from the finish line is actually decreases from actually starting from the 26.2 mile, right? Because she was right on the starting line. But now when she get there, it's going to be the 0 mile. Okay, all right, so that's about the number one. So I hope that you understand what is the meaning of the quantities, and then what is the varying quantity, what is um, the constant quantity. Okay, so quantities. So quantities are the attributes of the object. So I mean here. Okay, so let me see this. So quantities. So quantities are the attribute of the objects or situation you can imagine measuring. To clearly describe the quantity, we must include the object, description of situation, what attribute I'm measuring. So we have to know what are you measuring. Okay, so if I use highlighter, okay, so we have to know about what are you measuring. Okay, and then number two, where are we measuring from? So you need to know from where to where. You can just say distance to trajectory. So what? From where, right? So you have to say distance trajectory. This trajectory distance from the starting line or finish line. The direction of the measurement. So where it going? So it goes to the getting close to the finishing line or starting line. Units is important. So are they using miles or feet or units? It could be the hours. If they're talking about time, it could be the pounds for the weight, so we can change that too. So if the value of the quantity does not change, then the quantity called the fixed quantity, and it is a value of the as a constant. Okay, so and then I'm gonna go to the number two, but number two is more likely the next page I still need to talk about the varying quantity. So if the value of the quantity changes, then the quantity is called the varying quantity, and the quantity can be assumed more than one value. So keep changing, right? All right, in number two, I think I want to do the class exercises. So in exercise one, we relate to two varying quantity. So there's a distance in miles from the finish line of the race with the trajectory distance in miles from the distance line of the 26.2-mile race. So A, discuss with the classmate how to identify the quantities in the problem, statement, or situation. So B, what must you include in your description of the quantities so the another person listening to your description is able to imagine that the quantity and know how to measure it? Okay, so this is about the class discussion. So you can think about that too while we are learning. Okay, so we already talked about the variable. So let me talk about the definition. So when you have a variable, instead of representing the quantity value with a word, it is a more concise to define the variable to designating the sum letter, which is we all use x a lot, okay? Or you can use and, you can use whatever. To represent the value of the specific varying quantity can assume. So when defining a variable, we must be precise in describing the quantity and how it being measured by saying what quantity we are measuring. And then where are we measuring from? And then the direction of the measurement and the measurement units. So in exercise one, that the variable x represents that there is a varying number of the mile from the starting line of the race. In doing so, we write the x represent that there is a distance, which is a mile from the starting line, which is we call the x. That's why we can describe the there is distance from the finish line as a 26.2 minus x. So we then think of x as having a value that changes as Dejri run the race, so that it is always represent her distance in miles from the starting line. All right, let me go to the number in here in module 2 to 7. So let me go to 7. So in 7, discuss the useful variable for the representing the value of the varying quantity. Okay, so what usefulness of the variable? So if you're not using a variable, you have to using a long sentence to describe it. So if you use a variable, the variable is like a symbol of the or meaning of the whole sentence you just said. So I call the variable like a name. So once you have a name, that's what the person described, right? So it makes the sentence shorter. So, but the variable actually represents the any number. It depends on the cases, okay? And then B, it is important that when defining variable that we are specific in describing the varying quantity whose value are being represented by the variable designated symbol. So in the sentence D equal to error distance in miles and adequate definition of the variable. If not, what is missing and how might you modify this statement so that it defines a variable? So these represent the error distance in miles. So they are using the attribute objects, right? They're using the measurement, but they didn't actually talk about where it from where to where. So I don't want to say this is a complete the meaning of the whole things for the variable. Okay, so I want to say no for this one define a variable. So we might need to put it in as let D represent Aaron's distance, which is a mile. We had that so far same, right? And then you have to see from where. So where she is. So let's say she's west from her dormitory, okay? Or from her house, from her car, So you can change that to whatever things that you want to do as the adequate to the problems, okay? All right, let's do the number 8. This is more question is I think is nicely. So do I get the more problem? Oh yeah, I'm sorry about that. There's a C. When to define a variable, why it is important to describe where the quantity is being measured from the direction of the measurement and then measurement units. So what does that do? What do they do with those three things? Okay, so we need to think about the where the quantity being measured from, which is number 1, and the direction of the measurement, and then the measurement units. So without the reference points for the measurement, okay, which is number 1, without a reference point of the measurement, it is not clear, right? What quantity someone imagine. Or referencing. Now number 2, why we need the direction of the measurement? Because without the direction of the measurement, it is not clear what specific values of the quantity represent in the context. Of the situation. Okay, number 3. Why do we need the measuring units? Because the single quantity can be measured using a variety of the different unit, right? So if you just say about let's say number as a 2, what does the 2 means? Are they talking about feet or mile or yard, or inches, okay? So it could be a lot of variety of the different units. So when we have the unit with a number, that is important, okay? So because a single quantity can be measured using a variety of the different units. So you need to specify the units for the problem, okay? All right, number 8. Jenny's gas tank has 35 gallons of the gasoline remaining when she pulled into a gas station to fill her 25-gallon tank. Represent the quantities in this situation by. So number 1, draw the solid line to represent the fixed quantity of 25 gallons of her tank holds. Okay. So let's say this is the size of her tank. Okay, which is it holds the 25 gallons. Okay, so I'm representing the solid line. So this is much of the solid line to represent the 25 gallons of the tank. And number 2, draw the solid line to represent the fixed quantity of the 3.5 gallons. So 3.5 gallons are already right there. Okay, so still, there's a remainder here. So there's some gas in here. So which represent the 3.5 gallons. So draw the dashed line, and that is an arrow to represent the varying number of the gallon of the gasoline. So which means she need to add it this much amount. Okay, so this much amount is gonna be you're gonna say that as 25 subtract 3.5, and then you'll see the remainder here. So which means 25 minus 3.5, so it becomes a 21.5 gallons. Okay, so letter B, if the N represent the varying number of the gallons of the gasoline Jenny can add it to her tank, write the expression to represent the varying number of the gallon of the gasoline in the tank. Okay, so what if the Jenny not putting the 21.5 gallons of gas to fill out the 25 the gallons of the tank? So which means, let's say she putting the N gallons. Okay, so that means how much of the gasoline in her tank, which is they already have a 3.5 gallons, and then she adding to the N, but N can be more than 21.5 because 25 gallons is the max that she can fill it in. Okay, so that's a problem of the number 8. All right, thank you for listening.